Yeah, welcome everybody. My name is Brad Tallis, and welcome to this webinar where we're kind of talking about Fusion as a design and make. So I'm going to be covering the design side, and Umair is going to be talking about the make side. And I'm going to share my screen here real quick, get us started. Let's see. So I'm going to be talking about how we can go about creating like a manufacturable part. So you can kind of see my screen here. We got this kind of like what we're going to call like a spindle. It's got some threaded components. It's got some flats that are going to be, like mill turned. It's got some of these grooves in here, etc., some chamfers. I'm just going to kind of walk through how would you go about designing this. And then, like I mentioned, I'm going to hand it over to Amer, and he's going to talk about how we go about manufacturing this. With Fusion, there's usually multiple different ways you could go about making something like this. For example, you could start with a side profile and do like a revolve. And that's what we're going to do today. You could also almost think of this as what I call the wedding cake methodology, where you draw basically a cylinder, extrude that up, and then draw another cylinder, extrude it up, draw another cylinder, extrude it up, and just kind of keep building layers of the cake or layers of the part. You could totally design it doing it that way also. So again, multiple different ways you could go about designing this. I'm going to be using this drawing. This is what I'm going to be referencing to create this model. And you can kind of see it is in inch. So I'm going to be using inches. We can see a lot of like diameter symbols and stuff like that. And I'm going to be showing some tips and tricks and different methodologies as I'm going through this. I'll try and jump back and forth to this drawing to kind of show you what I'm doing. And we can see how, we've got the thread call outs, we've got the dimension call outs, etc. And let's go ahead, just dive right in. So I'm going to start out by making sure I'm in my correct units, which is inch. And then we always want to start out with a component. So I'm going to create a new component and let's just call it spindle. Okay, and then let's start with a sketch. And I'm gonna use that like that spun or revolved profile. So I'm gonna draw on my front plane. And one of the things I like about Fusion is I can kind of just mock up my design really quickly. I'm just gonna start to kind of draw the basic profile and then come back and kind of lock things down. So for example, I'm just going to start to draw the basic shape, and you'll notice as I'm drawing, you'll see a couple little icons appear, and these are the automatic constraints that are being created. So you can see these are showing like the perpendicular constraint. So as I get near vertical, it's kind of snapping automatically for me. So it's doing a lot of the intelligence for me automatically. So I'm just going to do something like this. Again, not worrying about dimensions. So I'll just do this and come across here. And I'm going to purposely, just end like that, for example. Then I want to have a line that this is going to end up spinning around. And you'll notice I'm in my sketch, and over on the right, I have this sketch palette. And one of the options is construction geometry, and then the other one is center line. And I'm going to go ahead and select center line and just draw a quick line that just goes up like so. Okay. Now, I talked a lot about these automatic constraints that were created. I can go ahead and click on like that point right there and say, I want that to be coincident with this line right here. And you'll see it kind of like snaps it over and says that point has to be touching that center line. And you can see it's now shaded in. And that's basically saying that this is a valid profile. We can do something with this. We could revolve it, we could extrude it, etc. Okay, so we have our basic shape. Now I can start to really kind of define it, start by using these dimensions. And again, referencing the drawing, I basically what I did is I started right here and I just kind of came across, drew up, came across, drew up, and just kind of worked my way along up to here and then across again. I didn't draw in this little radius or anything like that. We'll get to that here in a little bit, but now I'm going to come in and start putting in these actual dimensions that are the driving the actual size of my model. So I'm going to click on the dimension. And here's a cool little trick. Because I put in this center line dimension, if I click on it, and then, for example, this line, notice the dimension is kind of like floating out here, and it has this dimension icon. So I'm going to go ahead and place my dimension and type in 1. And we're basically saying that this is going to be a 1-inch diameter round profile. Okay. Same thing. I'll just go ahead and click the center line and that line there, place my dimension. That's going to be 1.5. And you can see how the drawing or the sketch is kind of updating as I'm doing this. And it's really quick. I just kind of come along here and let's just do the next one here. Just checking my drawing here and oops, I see I have a mistake here. So let's just go ahead and make that 2.5. And this next one is here. And that's going to be 4. And then you'll notice when I typed in 4 how that kind of changed a little bit. So I'm going to go ahead, just click and drag, and you can kind of see how it updates that. And then I can throw in my last dimension from there to there. And that is supposed to be 4.75. So I've basically defined like the outside profiles. Now I want to kind of define the heights of each of these segments. So for example, this segment right here, I'm just going to click on that line and that's going to be 0.75. And you'll notice that these lines are turning black as I'm putting these dimensions on there, and some of them are blue. When they turn black, that means they're fully constrained. They can't change. And typically you want to try and fully constrain your sketches. And what I mean by that is, for example, this blue line, it's not fully constrained. If I click on it, you'll notice I can move it. But these ones that are fully constrained, if I try and click on it, you'll notice I cannot change its location. The only way I could change them is by changing the dimensions that are driving the distances, basically. So again, you kind of want to try and fully constrain your sketches. So like, for example, this is supposed to be 1 inch, and you can see how the sketch updated accordingly. This here is 2 inches. And let me just move some of this stuff up a little bit real quick. Okay. In fact, one of the things I should do, I typically do at the beginning is I like to do the overall height so I don't get what you just saw there where it kind of overlaps. I like to kind of do the overall height. So let me do that really quick. I'll just do a dimension over here. And the overall height of this is 4.75. And you can kind of see how that grew a little bit. And then I can come in and say that's supposed to be zero 0.5. Now, here's something interesting. You'll notice the whole sketch is fully constrained, right? It's turned totally black. Well, I haven't put a dimension here. I want to specify that this is supposed to be zero 0.5. So I click there to put a dimension and I get a warning that says it's going to be an over constrained sketch. And I see this question come up quite often. It's like, why do I get this warning? Well, it's because we've already defined the overall height. And because of all of these other dimensions that we've put here, Fusion knows that this has to be zero 0.5. So if you ever see that warning, it's because Fusion already has all the information that it needs. Okay, so really quickly, I was able to just kind of, quickly sketch the overall shape, and then I came back and kind of defined the dimensions the way I wanted them to. to be exact, and I'm going to say finish my sketch. We'll use the revolve command, and hopefully you saw the cool trick there. Because we used the center line option, it already knew that that's probably going to be the axis we want to revolve around, so I didn't have to select it. It already knew what the profile was, so I didn't even have to click anything. And I'll go ahead and just say okay. Okay, so the next thing I want to do is let's take a look at the drawing really quick. And there is a large recess. Let me kind of zoom out here. A large hole that goes down inside of this spindle. You'll notice I didn't include this in my profile. I totally could have, but I like to do the easiest method. And we can actually use the hole command. So we can see that this is, 0.75 all the way through and 1.75, partially through. So this is almost like a counter bore. So that's what we're going to do. Okay, so I'm going to kind of look at it from the top, and I'm going to use the hole command. And I'm just going to kind of click somewhere on this top face. And you'll notice I purposely clicked not near the center. And the reason for that is I like to then grab the blue dot, and then you'll notice a blue dot kind of in the middle of the screen, or kind of like a white dot. And if I get near there, it's going to snap automatically to that. And that is the center of this circular face. So if I just get near there, it snaps to the center of that face. Then I can come in here and start to type in the information. And like I mentioned before, it's a counter bore. So I'm going to specify counter bore as the hole type. The overall diameter from the drawing is 0.75. Okay. And we want it to go all the way through. So I'm going to change the distance to say all. And now we can see that it's going all the way through. And then I want to focus on the counterbore section. So the counterbore diameter is 1.75. We can kind of see that updated a little bit. And then the depth, according to the drawing, is 2.875. And we can see the preview do that. So to me, I think this is simpler than doing a complicated sketch. I just used the hole command to create a counterboard hole that goes all the way through. And I like that because it keeps my sketch simple, and it's a feature in the timeline that I could come back and make a change to very easily, and try, instead of trying to remember which sketch was that on. Did I do it on my first sketch or my third sketch or whatever? Now, could I have used a sketch to do that? Absolutely. Okay. Let's go ahead and take a look at the doing these slots on the top. Next. Okay, so I'm gonna create a sketch on this top face here. And as we look at this, I'm gonna kind of zoom up here so you can kind of see here. This is, a curved slot. And we can kind of see the angle of 50 degrees between the two. And they're on a radius of 1.625 and a diameter of 0.5. So I'm going to kind of build that intelligence onto my sketch. Okay, so let's start with that circle. I'll go ahead and click. Now you'll notice it's asking for a diameter circle. Okay, but according to the drawing, it's a radius. Well, if I right mouse click, you'll notice it doesn't give me an option for a radius. So how do I do that? Well, all I'm going to do is just place my circle, and then I can come in and add a dimension. I'll click on that circle, and again, you'll notice it's asking for a diameter. But this time, if I right mouse click, you'll notice it gives me the option to do a radius. So I'm going to say radius, place my dimension, and it's 1.625. So that's one of my tips I wanted to share, is if you ever want to do a radius, You can as a dimension, okay? But not as when you're just creating the circle. You have to create the circle and then create the dimension. The other thing is I don't want this to be geometry. I want it to be construction geometry. So I'm going to select it and choose construction from my sketch palette because I don't want it to interfere with, being like actual real geometry. Now I need to know where those 2 points are to create that slot. So again, I'm going to create some construction geometry. So I'm going to choose line. I'll choose construction, and I'm just going to draw a line somewhere to this radius. I'm going to click there, and I'm just going to click somewhere over here. Okay. Then I'll throw my sketch dimension from that line to that line, and I want that to be 50 degrees according to the drawing. Now, here's where things get interesting. I want these 2 points to be horizontal. And there's a couple different ways to do this. In fact, I'm going to go ahead and put the slot on here to make it a little bit more visual. So, and then we'll fix the slot here in a second. So I'm going to change my line type to make sure it's regular. And I'm going to come in here and say slot. And you'll notice we have regular slots, but then we have these arc slots. And we have 3-point arc slot or center point arc slot. I'm going to do this center point arc slot. If I stop moving my mouse, you'll notice it says select center point of arc. So I'm going to click here. And then it says select start point of arc. So I'm going to pick that point there. And then it says select end point of arc. I'm going to pick there. And then I can just move my cursor. And now you can see it's allowing me to specify what the diameter is going to be. In this case, it's going to be 0.5. And I'll hit enter. And so now you can visually see that arc. But we want it to be perfectly like horizontal. Okay. So how could I do this? There's a couple different ways. I could come in here and throw a dimension from here, but I need a vertical line. Like I need this to be basically half of what that distance is. So I would have to create another construction line like so. That's straight up and down. And I could say from here to here, I'll place that dimension and I'm going to click on this existing dimension and it's referencing that 50-degree dimension. And I could say divided by 2 and watch what happens. It's kind of cool, actually, I think. I'm going to move this so you can kind of see it. It's basically taking whatever this dimension is and dividing it by 2. So if this dimension was, 60 degrees, we get the same result. You can see that that's 30 degrees, for example. So that's one way of doing that. So I'm going to undo all the way. Oops, actually, let me keep the, redo. Let me keep the slot there. I'm going to go ahead and leave it like this. The other way to do that is we could keep these 2 points. We want them to be horizontal with each other. So I could say horizontal, that point, and that point. And what we just said is those 2 points have to be horizontal with each other. And you can see how that basically made the two lines rotate to be lines straight up and down, basically. So to me, that's quicker, less geometry, less dimensions and stuff like that. But like I mentioned at the beginning, multiple different ways to get the same result. Okay, now could I pattern this slot in my sketch? Yes, I could. But I like to keep my sketches as simple as possible and let Fusion do the hard work. So I'm going to go ahead and machine this. So I'm going to say extrude. I'm going to start to, cut that down. Um, and let's go ahead and tell it what the distance is. Now, I don't know what the distance that I want to cut this is. I know where I want it to go to. So I'm going to say to object. Okay. And I'll select this face. Now, instead of typing in, like, I know that this is zero point 0.5 and that's zero point 0.5, so I could have typed in 1. I always like to use the to object and selecting that face. And the reason for that is if you ever come back and make a change to your design, so for example, if you decide to thicken this to be 0.75 and 0.75, that hole or this slot will always go to this object. So it's always smart to use to object or all, etc., instead of typing in distances, because you never know how your design is going to change down the road. Okay. And let me show you what I mean by that really quick. Hopefully we have time to do this. I'm going to undo. Let me just extrude this, and I'm just going to say, for distance, I'm going to say, let's just go -1. Okay. And we get the result that we would expect. But if we come back to our original design and I change that to be 5 inches tall and we finish our sketch and we look at this, notice it no longer goes through the object because we told it to go 1 inch deep, and that's exactly what it's doing. However, if we had told the extrude, instead of going distance, we had said go to object, and now we come back to our sketch and we change that to be, 6 inches tall. You'll notice it goes all the way through the object, right? So no matter what, it's going to do that. So I always recommend using the to object. Okay, now I did one in the sketch, and I can come in here and say um, pattern, circular pattern. And then you'll notice the object type is bodies, faces, features, or components. And I'm going to go ahead and say features. And I'm going to select this extrude feature. And you'll notice by selecting features and then just selecting this extrude, it grabbed all of the faces of that feature. I didn't have to come in and manually select all 4 faces. In fact, check this out. I'm going to cancel and show you a cool little trick. According to the drawing, and you'll notice you can kind of see it here, it says all chamfers are 0.02 unless otherwise specified. So there's a lot of chamfers on this part. I'm going to go ahead and select one edge, say chamfer, and say 0.02. So I just chamfered the top edge of that slot. Okay, now I'm going to do my pattern, circular pattern. I'll say features. Not only am I going to select the slot, I'm going to hold down my control key because I want to control my selection. I'm going to hold down my control key and select that chamfer also. It selected all of the faces of that chamfer. What's my axis? I'll just select anything that's cylindrical. We'll crank that up to 4. I'll say okay, and we now have the 4 slots that are going through. And it did the chamfers also. Now, why did I do the chamfer before I did the pattern? Well, I could have done the slots, but then I would have had to select that edge, then this edge, and then this edge when I did the chamfer. So I saved myself some time by selecting one edge and then patterning that. So again, just saved some time. Okay. Okay, then we're almost done with this part, believe it or not. We need to add the threads, we need to add the hole, and then we need to add the hex flat faces. So I'm going to kind of cruise through here to make sure I give enough time for Umair to machine this part. So I'm going to go ahead and let's do the threads next. So I'm going to come in here and say create thread. And all you have to do is select on the face and it recognizes the size of that cylinder. So it recognizes that as 1 inch. And then I can come in here and specify the designation. So according to the drawing, these are 1 by 12. So I'm going to just select that and say OK. Now here's a cool little tip. You'll notice it kind of looks like a sticker or a decal. That's to simplify the design. If I check modeled, it'll physically model this. So if I needed to like 3D print this, for example, I'd want to have it modeled. But if I'm just sending this to be like machined, I don't have to have this modeled. The drawing will be correct. It'll actually have the correct thread call out and everything. So I would leave it turned off in this case. I'll do that again. Let's say thread. I'll pick on this one here. That's a 1.5. So let's go ahead and do the 1.5 by 12. Say okay. Okay, and then the last one is there's a hole that goes through here. So I'm gonna again use the hole command. And here's a neat little trick. If I just click somewhere, so I'm looking kind of near the front. If I just click near the front, it's actually gonna pick on the front face. Now it looks weird because this is such a big representation right now. So I'm gonna change it to a simple hole. And then I can select a reference. So I'm gonna reference this bottom face right here and type in 0.75. So now the center of the hole is 0.75 from that bottom face. Okay. Then I can come in and say, okay, that's supposed to be a threaded or a tapped hole. And it's supposed to be, what is it? Um, 1/4 inch, looks like, according to the drawing. And then again, it's just kind of going all the way through. Instead of a distance, I'm going to say go to, and I'm just going to select like that inside face, like you see there, like that, and call it good. I'm just going to say okay. And it created that hole exactly where, on that basically tangent to this face right here, planar to that front face at the correct height of 0.75. Okay. Then the last thing I want to do is create kind of like the hex on here. So let's go ahead and create a quick sketch. And I'm going to use a cool command in here called polygon circumscribed polygon. And then what this allows me to do is I'm just going to go ahead and pick like a center point. And then you can kind of see it's going to create a six-sided polygon. And here's the edge number right here. I could specify, 5, 6, 7, whatever I want. But in this case, I want a six-sided polygon. And I'm just going to do like 1.175 in this case. Okay. Now, what I basically want this to do is remove some material here. So I kind of need to create a circle outside of this, like so. And hopefully this will make sense here in just a second. In fact, I'm going to rotate isometrically so you can kind of see what's going to happen here. But we're going to use this region here to kind of machine away. Okay. So I'll just come in here and select that region and say extrude. And make sure I select those little regions there also. Start to drag, and you can kind of see the flat, what it's basically doing there. It's using that polygon and removing away. Now, how far do I need to extrude? I don't remember the distance, and I don't need to. I'm going to say to object, select that face, and it's going to cut away that flat area to that face. And again, if this length were ever to change, it's always going to go to that face. Okay, and then the last thing is to add these small chamfers. I'll just select one face or one edge, I'm sorry. Um, a cool little trick is if you've ever typed in the number before, so I've typed in 0.02, you can click these three little dots right here and it remembers any of the stuff you've typed in before. So I'm going to select 0.02 and then I can just come in and grab any of these edges that I want to chamfer. So I could grab these guys around here real quick, like so. And maybe something like this and something like that. Okay. And we'll call that good. So I'm going to go ahead and save this. And I'll just call it spindle and I'll hand this over to Emer. Okay, so let me stop my share.
Perfect. Well, thank you, Brett.
Yep.
We're going to do induced stress machining is what I call it. But yeah, so in the rest of the remaining time here, I'm going to go ahead and walk through pretty much machining the part that Brad just created. So, I mean, that's just similar to any sort of standard shop that you're going to walk into if they do their design and make inside of Fusion. So in this instance, I'm looking at the model that Brad gave me, and due to the power and the convenience of cloud data sharing, I'm not walking around with a thumb drive or anything like that. I can just pretty much see exactly where the file is that Brad wants me to open, and I will go ahead and click on that. It's also a nice little trick here that I know that Brad's actually in that file just by looking at his initial there on his name. So perfect. There's the part. I'm looking at it. And, it's my job as a machinist to make Brad's life really hard and tell him exactly what are the things that I don't want to be machining on here. So, Brad, I noticed a small thing here as far as like the threads. Now, usually, we prefer to have a little bit of an offset in here to make some clearance for that thread. How easy would it be to just do that really quickly before I program this?
I should have totally thought of that. Thanks. I will fix that right now.
Perfect. Again, this is the beauty of the data collaboration on the side of Fusion. So while Brad's doing that, kind of walk you through what my process is going to be here. This is certainly going to be a 2-op part. So we'll throw some turning operations on here. We'll throw some hole making operations, the classic deburring there as well. And because of all the flats and things like that, we will also create some mill turn operations in there as well. And then we're going to see if we have enough time here, but I think we should. But I'd like to also maybe touch on some part transferring. If you did have a mill turn machine with your primary spindle and a sub spindle, how would we make that work? Confusion kind of grab, an area in here and then use the sub spindle to create the op number 2. So that's going to be pretty much how I am going to tackle this part. How are we doing there, Brad? Ooh, the pressure's on.
I just made the change. I just saved it, so you should hopefully get
Perfect.
notified. Oh, yep, there
Oh,
it looks like.
excellent. This is good timing because I can see, as you can see now, there's a alarm there, right? There's an alarm showing me that this is an older version of this file. So it's telling me that, hey, someone's actually updated this file for you. So again, no need to bring in a new file, no need to go look for it on a network somewhere, nothing like that. With the click of the button, I am now capable of looking at the newest and improved model here that Brad has created for me, right? So now some of you may think we planned that. We didn't, but all right. So let's jump into the manufacturing side. I'm going to go into here. Perfect. All right. So on the manufacturing section here, there are a couple of different tabs. We're going to be mostly on the turning side here to begin with. So I'm going to go ahead and create a setup. So I'm actually going to hide my data panel so I can get a little bit more room, a little bit more real estate. And we're going to go ahead and create that setup. Now, notice what happens as soon as I do this. When I click on that setup menu, Fusion already kind of looks at the conical nature or the concentric nature of the part and assumed that it was a turning or mill turn part. I'm not sure how they really do that, but I think that's really smart. So from here, all I really need to do is select which z-axis or which z direction I'm going to be starting with first, right? So I think bulk of the material removal is going to happen on this section here. So I'm going to flip my z-axis. A couple of things I can do there. I can pretty much just click on the arrow, or I can also click on this checkbox here to flip that over. Now, you could, if you want, orientate your x-axis as well to a certain face, but if you don't have to, we don't really have to do it at this point as well.
Hey, Umair,
Oh,
quick question.
right.
Just yeah,
Yeah.
I'm about to say, yeah, quick question came in about are you going to include using a CNC probe for alignment?
Not today. No, that would take a little bit more time. So unfortunately, it might not. But that's a really good topic for us to jump into a different time. Perfect. Thanks for the question, Chase. All right, so we're gonna get that our axes lined up here, and then from here, pretty much setting up some stock. So let's go ahead and say, you know what? Let's make this off of a maybe we don't need too much, but maybe about an inch or so for us to grab into the chuck, right? Let me just add that in here. Perfect. My stock diameter can stay at 5 inches. And then what's also super nice is I can actually offset it from the front or the back. Now, typically I always kind of go off the front here, and maybe we just want to face off a few, maybe about a tenth of material off the top there, right? So just a little offset there, and that's pretty much it. I'm gonna hit OK, and there's my setup, right? So again, we're going to be clamping on the chuck somewhere up here, and now we can get started machining here, right? So as far as the toolpaths that I'm going to be using today, all of the turning operations are listed underneath the drop-down menu right here. You'll notice it's almost organized chronologically. So we're going to start off with that facing operation. Now, some people prefer not to, some people do. So again, really depends on what your style of machining is. We're going to go ahead and select a tool. And hopefully, just by the number of clicks here, you'll see how convenient it is to get this done. So I'm going to use some of these Fusion library tools here. They come standard with Fusion, so that way you know I'm not doing any trickery with some custom tooling here. We'll go ahead and use this, maybe this right-handed tool here, and we'll go ahead and hit OK. Now notice just as soon as I pick the tool, I get a preview of the toolpath, right? I get a preview of the toolpath, I get a preview of where it's cutting, how it's entering. So the work that you have to do here after is really more kind of optimizing the toolpath to what your needs are. Adjusting feeds and speeds, maybe selecting exactly where you want to cut to or where to cut from. So these are all more kind of optimization, but as far as getting the toolpath set up and getting a preview, you notice it's just about picking the tool and hitting OK. And there we go. You'll see a transparent stock here. That way you can kind of see exactly how much we've cut away. All right, moving on to the profile roughing. So I typically use the profile roughing to get rid of all of this material here. Before I do that, though, I will mention that profile roughing isn't the only option. If you do enjoy using stuff like grooving cutters or even rounded cutters, we do have a couple of different options there as well. So you can use the groove roughing operation. That does great with grooving tools. And then the adaptive roughing toolpath is also really cool. That helps kind of keep constant load on the tool, and it's much better suited for rounded cutters, right? So I'm using option A, but there's option B and C as well.
Hey, Umair, one more question came in.
Yeah,
Is there any command that is similar, like quote convert entities SolidWorks or quote flash shot AutoCAD?
interesting. I'm going to assume there that that question is based on maybe extracting a spun profile of the part. Maybe somebody can respond to me, whoever
Yeah,
gave
I'll
me the
see.
question.
I'll see. It was sent
Perfect,
by
perfect.
Sync. Yeah, I'll keep you
Okay,
updated.
yes, if that's the case, then yes, Fusion does have the ability for us to create a spun profile, a 2D flat layout of a turned part. Yep. Okay, moving on to the roughing here. So again, as you can see, I used that tool last time, so just gonna keep it in there. I have the ability to select a different tool if I wanted to, right? But in an attempt to kind of convince you how easy it is to do turning operations in Fusion, I'm going to pretty much just hit OK. We're going to let Fusion tell us what it's going to cut. And as you can see, I mean, that is a pretty good toolpath right there, right? Finer adjustments can be made to how, again, your feeds and speeds, for example, where you want to cut to. As an example, let's just say, you know what, I actually don't want to cut all the way to the back here. Maybe I only want to cut to this section right here, right? I can easily just use a slider, or I can also actually select a position if I wanted to, right? So maybe let's just do this. Let's go all the way up until here, and then we might want to machine the back end, right? With some different stuff. Maybe we go halfway, just so you can see what the difference looks like. So as you can see, Fusion will now only cut to that area. Fantastic. All right, so next step that I'm going to do now is I'm going to create a finishing operation. That way we can make sure, now the roughing operation is good, but as you can see, because of these little steps and these motions that it makes here, it's never, in my experience, it's not the best operation to finish off with. You always want to finish off with an actual finishing operation so you can get a cleaner finish off of these flat faces here, right? So I'm going to go ahead and do that, create a profile finishing operation. And maybe let's choose a different tool, change things up a little bit. So I'm going to use let's go back to the Fusion library, just a standard library. And let's use let's use this one, the VNMT right hand, right? A little bit of a sharper back angle and a larger insert, I believe, radius to get a better finish off of that. Perfect. Again, same thing, not going to do anything different. I can just hit OK. And you'll notice it does a one pass finishing operation, right? Now, something I do want to mention is you may have noticed on that previous roughing operation, because we set it up to only go to that limit right there, the finishing operation doesn't really know that. So potentially I could have taken a lot of material off right there, right? Now, and I kind of did that on purpose because I wanted to show you something. You can, let's just say you created this toolpath and you had some preferred uh, stops and things like that, or some preferred parameters in there. You can also create something called a derived operation. By doing that, what you can do is save a lot of those parameters and you can swap the tool really quickly. And now if I hit OK, you'll notice it actually stops at that position. Because by creating a derived operation, you save a lot of these different selections and parameters across all these different tabs right here. So I think it's a really, really cool way to kind of save some time versus trying to cut stuff. And here I'll point out another change I'd like to make, or a modification I'd like to make as well. Notice how the tool is just trying to plunge into this area, right? The reason why is because it didn't do it on this one because the back angle was farther enough with that tool, right? But because I'm using a more sharper tool and a steeper back angle, technically Fusion thinks, you know what, that tool can fit in there, right? Now, if I want to make that a little bit more cleaner, a really simple change that I can make in my passes tab is to tell it not to actually do any grooving at all. So if I say don't allow any grooving, we should hopefully see a much cleaner toolpath right there. All right, so a few tips and tricks to kind of help you on your way there. Fantastic. So we're looking pretty good here, right? We've kind of roughed everything out. We've finished it out. And so a few things I'm going to do now is just kind of do a threading operation and the hole making as well. I'd like to tackle the hole making from the next setups. That way it's all kind of done from one side here. So let's go ahead and get that done. So let's go ahead and do a single groove. A single groove is really useful here because I just need a grooving tool to come in, create that notch for me, and then I can back it out all in one, right? So we do have an operation for that. Funny enough, it is actually called single groove. So we're gonna use a tool here, and again, using some sample libraries. Let's see if we have a grooving tool. I believe we have one right here. And select that. Now I can immediately notice that's a little bit wider than the actual part is. So if I need to just go ahead and edit that tool, I'll just go back into my tool selection, edit that tool. And I believe Brad may have made that about 50 thousandths, correct, Brad?
Yeah, 50,000.
Correct.
Yeah, sorry, I was on mute.
Oh, you're totally good. There we go. So I'm going to make that tool 50 thousandths as well. I'm going to hit accept. And now I just need to select where exactly the position I need to send that tool. So now in my geometry tab, I can select this arc right here or this edge right here. And then you'll notice I just need to make sure that it's got the right alignment, right? If I have it set to middle, you'll notice that's going to be bad news, right? So if I hit OK, you'll notice what it's trying to do. It's actually going to take off this face right here. So you got to be mindful of where exactly the alignment is. I'm going to change that to either the front. Yep, it's going to be the front. There we go. And what's nice about that is you can also do two edges at the same time. So I can select that position and this position all in one toolpath and hit OK. All right, we're looking pretty good. Okay. I'm going to wrap this side up by doing my threading, right? So now for the threads, again, you can look at the print and the call outs and we can create the right tool for it. So we're going to go ahead. And also I should mention.
Also got one more question, Umair.
Yeah, Chase, go ahead.
Yep. John asked, what would you do if you wanted the groove operation before finishing the overall part?
Before finishing the overall part, you can simply just create it and drag it to the top here. And now you'll notice I can change my order of operations. That's a really good question, John. Perfect. So yeah, there's no real order. Sometimes a little chaotic. I just make toolpaths and then before I post them out, I'll make sure that they're the right order of operations. Yep. Okay, good. Going into the threading side of things, and what I was going to mention was, now obviously this specific toolpath here is meant more for an insert, style threading cutter on a lathe or for turning operations. But if you wanted to thread mill this as well, you can certainly do that. We would just use a drilling operation with a thread mill or a thread milling operation, the milling setup. You can achieve the same results, right? All right, so I'm going to go ahead and use a tool here. Let's go ahead and grab something from the Fusion library. And then here's an OD threading style cutter. And now this does come with an insert on it, right? I'm not going to spend too much time here because I don't have the geometry for that insert, but I'd like to show you just quickly in case you wanted to change the size of the insert and things like, and the pitch, you can simply go back into that tool, edit that tool, and then you can put in the pitch for that specific insert that you purchased. So good way to find that out is if you're on the website and you have product information, you should be able to get all of that dimensional values for that product, right? So let's just say as an example, I'm not saying this might be fully accurate here, but the pitch be 100 thousandths or so. And I might need to change this here to make it a little bit bigger. See if I can get that to change. Let's do this. Let's do one. Let's just say it does a 1 divided by half, right? And let's make this a little bit bigger, maybe even an inch or so, right? So really quickly, you should see, now I'm obviously over exaggerating. This might not be what the insert actually ends up looking like, but you can change the size of the insert by just messing with the pitch dimensions and your overall and width dimensions as well. Okay. For comedic reasons, why don't we just go ahead and use it? That's a pretty big insert there. So as far as selecting where exactly you need to thread, it's easy as selecting the actual conical face, right? And let's just say these were the same threads, these were the same pitches and everything. You can pretty much select both faces too. It'll still give you individual turning toolpaths here, turning toolpaths. Confinement is a way for you to be able to adjust exactly where it starts and where it ends, right? Now, you don't have to do that either. You can also just change the offset values automatically right here. So let's just say, you know what, I didn't want the threading to start all the way from this offset right here. I can just make that offset a little bit smaller and you'll notice now it only starts about ½ an inch before the actual threading face. And now this is always a good thing to do. That way you can, make sure that your threads don't get, your first leading threads aren't terrible. It starts the threading cycle prior to engagement on the part. All right, good. On the passive side, you can change exactly how many step overs you want to do, or sorry, I should say step downs you want to do. You can change things like your in-feed mode, right? So the options are there. Don't want to spend too much time on it here for the sake of work. So we're going to hit OK. There we go. Fantastic. So that's kind of, the first setup there, pretty much good to go, right? And now we just need to get it to the secondary spindle, do a part swap, and then let's work on this side right here. So in order to do that, it's honestly really simple. There's a subspindle grab operation right here that we can use. And I can tell it, you know what, I'd like my subspindle to come in and grab a specific spot. So like, for example, right here. Remember, this is the face of that collet or that chuck, right? Hit OK, and then now it'll output. Now we're not going to see anything here virtually showing you the grabbing operation, but it will post out the specific M code that you need for that machine to produce that subspindle grab, right? And now this one, so that was the grab, right? And now we need a return to get back to the position. So what it's going to do now, it's going to unclamp the primary spindle, right? And then it will receive back to your subspindle home position. And that's it. Perfect. All right, how are we doing for time? We got 5 minutes. I think we can get this done. All right, so now for my second setup, what I'm going to do here is there's a couple of things you could do. You can either duplicate the setup, right? Or you can actually create a new setup. So let's go ahead and create a new setup. And then you'll notice my Z axis is actually now on the preferred orientation I need it to be on, right? And my stock here too, you'll notice Fusion has the ability to look at it from my preceding setup. So whatever was left, all the material that was left over from the previous setup is what we will see on here. I always like to check this checkbox here, the continue rest machining. That way we're not spending too much time air cutting on things that have already been cut. All right, good. Now let's go ahead and throw a facing operation here, get rid of all this material. So I'm going to do a facing operation. Use that same right-hand cutter again. Right, and now what we're going to need to do though, as you can see, the Fusion thinks is we only need to do one pass, right? That's clearly not going to work. So in my geometry tab, what I'm going to tell it to do is actually don't pay attention to the front of the model, pay attention to the front of the stock, right? So what we're going to do is we're going to go ahead and select stock front instead of model front. Okay, and now for my passes, I need to tell it to do multiple passes. I have enough passes to get that done, right? Actually, sorry, I do need to have this set to model front. Perfect, there we go. Now these number of passes will be calculated so that we can cut all that material off versus just having the tool dive right into that section. And remember, there's a couple of different ways you could do this. This is just cutting it down vertically. If you want to do horizontal passes, you could do horizontal passes as well, right? Perfect. All right, so from there, we can also do a quick finishing operation or a roughing and finishing operation. Now, what's super handy is you can also copy toolpaths. I'm going to copy a few from the top section here. So right-click, copy, and I'm going to paste that in here. All right. Now notice what's really fun here is I can just adjust where exactly I want to cut to, right? I can say, I only want to rough and cut to that section there. And there it is. Same thing for the finishing as well. Since I copy pasted it, I can just simply drag that back plane all the way up to here, say, okay. There we go. We're getting there. We're almost there. All right, perfect. So now I just got to knock out a couple of holes and some slots, and we can call it a day. All right, so, oh, actually, no, I've lied. We can't. As a machinist, I would love to call it a day, but I can't. I still have more features in here that Brad wants me to do. All right, so now as far as doing some milling operations, right? You can quickly convert this into just from a turning part to a mill turn by just swapping over to the milling tab and using a lot of these milling operations. Now, what's really nice about this is I don't have to worry about resetting a new setup to call it a milling operation or anything like that. My Z direction is also really, it's in the right direction for my tool. So I'm going to stick to a cutter. And let's go ahead and grab a milling tool. And let's use a flat end mill. I'm not sure exactly what size those slots are, but we're gonna give it a try here with a 1/4 inch. It looks like a 1/4 inch will fit in there. Fantastic. All right, so we get a preview of the end mill, and now remember you need to have live tooling to do this. And for my pocket selection, I can select this edge right here at the bottom. And I'm gonna go ahead and have Fusion just give me an idea of what the toolpath's gonna look like, right? So as you can see, it is going to ramp in. You following the profile is gonna cut into that pocket. A few things that I'm going to do to improve this is obviously I don't need to ramp from that level, right? So for my heights, I'm going to adjust that and say, you know what, I'd like to feed from the actual top of my model and not from the top of the stock, right? So we can make some adjustments there. I'm going to go ahead and hit OK. As you can see, that trimmed up that toolpath a little bit for us. Now it is ramping. We can also, for example, add more step downs. I can say don't leave any stock, right? So there's a bunch of different options in here that you can change to make sure you get the right cutting parameters. I'm going to hit OK. Perfect. Now, what's super handy here is I know I have to do that 4 times. I can pretty much just add that in one toolpath by just picking all 4 chains. Now, Fusion does have the ability to also pattern operations. You're going to see that here in just a bit. All right. Next thing, we're going to knock out this massive hole in here. So I'm going to go ahead and use a drilling operation. Select a drill. Thank you for everyone who's going to bear with us here just for a little bit as we finish this part off. I'm going to skip the spot drilling and stuff like that. And
Yeah.
also a little handy trick is if you hover over the actual hole, it can give you the diameter. So if you're like me and you lost the print, maybe 30 minutes ago, you can actually just hover over the tool, the model and find out what you need. So we're going to knock
Yeah.
that out go ahead, Brad.
Come here. I was just gonna say you're good. I threw out a comment saying we might go a few minutes over, and everybody was like,
Excellent.
"Hey, we don't care. We're learning a bunch of cool stuff." So you're
Oh,
good in
perfect,
there.
perfect.
So
As long as everyone's cool to hang.
yeah.
Should have made this a longer session, but this is fun. All right, I'm gonna just knock this out with a 3/4 inch drill. Now, I know people are gonna come at me and say that's crazy talk. We should be pilot drilling that, and I completely agree. So make sure you are stepping up as needed, depending on materials and things like that. But for the sake of the webinar, we're gonna jump right in and shoot a hole in that thing. Perfect. So again, you'll notice I don't have to worry about doing anything with multi-axis because this is all in the right Z orientation for us, right? I'm going to pick that whole face that I need. Fusion is going to give you a preview exactly where that position's at. And then here's a really, really handy feature. You can use something called auto merge hole segments. And then actually here, I'm going to do it without it first so you can kind of see the difference. So notice, yes, I am drilling this hole, but it's actually plunging right in, rapiding right in and starting to drill only from that position. Why? Because that's kind of the circular edge start and stop for that hole, right? But Fusion can be a little bit more smarter. So we're going to tell it to use this feature here called auto merge hole segments. Now, if this was done with a counter bore and we hit OK, oh, in this case, it wasn't as smart as I was hoping it'd be, but that's all right. The auto merge hole segments works really well if you have things like a countersink or counter bore where you can offset the toolpath to start just above it. So in this case, because it is not working, simple fix, just using a heights tab update will make it work as well, right? So for my top height, I'm going to go ahead and select top of the model, right? We're going to start from the top of the model. And for the bottom height, actually I did tell it to drill the tip through the bottom, which is convenient because in case you did swap the tool with a different tip angle, it will update that as well. A little bit of a cleaner cut. Let's just go past about 100 thousandths or so. And then do not forget the drilling operation, right? So, I mean, yes, it'll be great to just send in a nice through cooler and carbide drill through this part and knock it out all in one pass. But if you're using any other sort of drill, you do have the option to peck drill as well, right? So make sure you do choose the correct drilling operation. Perfect. Now that we've knocked that hole out in there, I can also go ahead and use another pocketing operation or even a 2D bore operation to rough out the rest of this material right here. So let's go ahead and do that. I'm going to use a 2D pocket. We'll use a much larger tool. Maybe we step up to about a 1/2 inch now. And plus we can't do that because we just drilled a 3/4 inch hole in there. So we'll use a 1/2 inch flat end mill. Gonna hit that, select that. Again, really easy. Just select the bottom. You could use you can use the edge here. You can use the face, whatever you prefer. And then if I hit OK, you'll notice that it's going to helical in there, right? And what I'll do to change this is, so here's what I'll do. In my linking tab, what I'm going to do is I'm going to say actually just plunge in, right? We're going to do this all in one pass. So plunge in, and we could do a pre-drill position and select this center edge here, right? But I'm now, because I'm trying to do that all in one step down, I definitely don't want to do that all in such large step overs, right? So we're going to change that to our maximum step over here can be a lot lighter. So let's just say, you know what, we do maybe about 30,000 pass or something like that, right? I hit OK. So as you can see, the convenience there is you just plunge right in, and you start spiraling motion out, you start cutting material out of there, right? Now, again, if this is a little too dangerous looking, always add a multiple depth in there, another pass as you need. And a really nice little trick that I also liked to do is you can also edit expressions in here. So editing expressions can be set up for that specific parameter where you can say, you know what, I wanted to do a certain percentage of the diameter or a certain percentage of the flute length and things like that as well, right? So let's just say maybe we do about 0.5. Oop. There you go. So as you can see, you can change that as needed. Trim it up a little bit more here too and say, you know what, I don't want to start from the top of the stock. I want to start from the top of the model. Go. Perfect. So we pretty much wrapped that up in there, looking pretty clean in there as well. All I need to do here is cut these flats in here. So this is where I think it gets really cool because this is some more like, you know, Milturn specific stuff. For this one, I would probably do, you could do a 2D pocket as well, right? So we can do a 2D pocket. Now, clearly the tool isn't in the right position here though, right? We need to get the tool in the back end over here. This is where I go to the multi-axis operation, the tab, sorry. I turn on tool orientation and I select my Z-axis and I say, you know what? This is the axis I want to select. Notice what immediately happens. My Z-axis is now not facing the direction of for the other tool paths. It is in line with the face or perpendicular to this face right here. Perfect. By doing that, oops, sorry. One more thing I forgot to do is select where I actually wanted to cut. I can select this face right here, and we can let Fusion give us an idea of what it's going to cut. As you can see, we now went from using just your standard Z-axis here to a more Milturn specific type of cutting, right? Now, what do I do for the rest of them? Right? I would still need to, would I need to make 4 different toolpaths here for all 4 different cutouts? Not necessarily, because what you could also do is you could, let me just take this to no stock here so it looks finished. What you could also do is throw this into a pattern. Now, Brad has given me 1, 2, 3, 4, 5, 6 faces in here that need to be flat, right? So I can simply right click, say, add to new pattern. We're going to do a circular pattern. Pretty much, this might look familiar to how he actually put in these patterns for the slots, right? Select a center line for that, for the axis. I also use that face so it's concentric. And I now put in the number of times I want the toolpath to run. So I'm going to put 6 times, and as you can see, that cuts all 6 of those flat faces. All right, how we Are we chasing any questions? How's it looking on the chat? I see the chat
Yes,
going up
few.
here.
Yeah, it's
Man.
been bumping. Good group today. So okay, so we had one Chenk, I think is how you pronounce his name. I'm sorry if I'm mispronouncing that. He was asking, so this was kind of a follow-up to a previous question, but they were wondering if there was any possibility of showing the project command at the end of the webinar.
Yeah, project command. I don't know if he was talking about the spun profile
Project.
Yeah,
command
yeah,
or just regular project. Yeah.
I can totally do that right now. Let's go to design. And what I would do is I would just create a sketch first, right? And by creating a sketch, now you can go into the sketch editing mode. And if you go into your project include, there is now the spun profile operation. Click on that. You select the body. You can choose to, link it or not. And the axis, I need to select this center line axis right here. And we hit OK. And there's our spun profile. What's also cool, Brad, is you can see it does the internal too, the one that you were talking about.
Yeah, turn off the body so they can kind of see what it did.
Yep,
So
absolutely.
yeah, there it is. Yep.
Hopefully we answered that for you.
Yep. He said, awesome. Thank you.
Perfect.
Yeah, thanks for asking the questions, everybody that attended.
Absolutely. We enjoy the questions. What else do we got, Chase?
Let me see. Brad was doing a good job answering some of the basic questions in chat.
Perfect.
Yeah, I think we're all squared up now. Let me see if
Perfect.
there's anything else that's coming in.
Yeah, there was one
Yeah,
question, Umair,
I think
about,
this is
were we
cool.
still in a mill vise? And I said we were still in a, the spindle, right?
Correct. We're still
Yeah.
in the spindle. Yep. Yep.
and
So
Kevin Curry just asked a question. Might need to be a little bit more specific, but maybe you know what he's talking about. He just put part handoff question mark.
Yep. So the part handoff happens here. With our subspinal grab and our subspinal return. So like I said, unfortunately, I can't visualize it at this point right now. I know it is on their public roadmap to add, turning simulation here instead of fusion. So we're hoping when it comes to that stage, we might be able to kind of see that happen virtually. But for right now, you can use a subspinal grab operation and you can use the subspinal return operation, and that will produce the correct M codes in your NC code for that trigger to happen. Hopefully that answers that question. I will also mention one more thing if we're also in here. You can create manual NC as well, right? By creating manual NC, you can do a pass through and then type in any sort of specific macro or a routine that that you need to add for that the grab and the return to take place, right?
So, Umair, quick question for machining
Mhm.
those flats on the OD, how would the part be fixtured?
Oh, okay. So if you can visualize, right? If you can visualize, remember when we did the subspinal grab and subspinal return, so we are technically clamping it right here. So maybe if can I draw? Can I draw? Yeah, we could draw. We could draw. So think about the oops. Think about the chuck being somewhere there or holding out of the part somewhere there. So now your tool can come in, if it has enough clearance, be able to cut that pocket right there.
So you would cut the flats before we did the threads, right?
Yep, yep,
Yep.
yep. Oh no, no. Okay. So I see what's happening. Yeah. So we would, so if we're holding out, let's just say there were no threads here, that would probably be best, right? So
Mhm.
maybe we didn't think about that all the way through, Brian. We shouldn't be holding on to threads.
Right. That's
But
why I was asking the question. Yeah.
exactly, yeah. So like let's just say, for example, if this was a cylindrical boss instead and the
Mhm.
clamp was holding on to it right here, then yes, we could totally cut that right there. Or I mean, we can also come up with some other cool ideas to hold this in this
But
other.
like you showed earlier, it's as simple as just reordering the order of the tool paths, as you're going
Right.
through saying, oh wait, I gotta move, the creating these flats before I do the threads. And it's really
Absolutely.
that simple. And the other thing I wanted to point it out is we came up with this idea, modeled the part, created the tool paths, and cut this part in less than an hour, right? Like the fact that you can do all of this in one tool, literally this quickly, I think it's pretty amazing.
Yep, yep. And I think I also made I might have a flaw here in exactly how I attempted to do that. You could have done the flats, right, in that first operation versus sorry, the first setup versus doing it in the second setup, right?
Yeah.
So so then that way you would have been we would have been holding it in the current fixture this way, and then we could have done the flats here. So yeah,
Yeah.
that's a
Good
flaw on
point.
my part as far as organizing that, but 100%. Thanks for bringing that up. Yep, Tony, totally correct.
I think I think we're all caught up. I got a little distracted there, so I'm assuming you responded to Norman and Tony right there, Umair.
Yep,
Okay,
yep.
awesome. Awesome. Okay. Well, I have sent you guys the links. We have gone much longer than I expected, but that's awesome. So yeah, these are monthly webinars that are typically focused on the CAD side of Fusion. We are definitely wanting to, this was kind of an experiment to bring both sides together. Something that we really want to do is continue to, provide more of these on both the CAD and CAM side. So stay tuned. We have hired a new guy recently. He'll be the one that's doing the Fusion training in December. And I think at the beginning of 2025, we'll be kicking off a lot more regular Fusion-based content and live streams a lot like this. Even more interactive, I think, is kind of the goal going forward. So yeah, since you all have been registered already, you'll get future communications about live streams. I'll send you all a link to this recording by the end of the day today, so it'll be in your inbox. And check out some of the other information I sent in the chat here. Make sure you get your free trial. Make sure you sign up for the free training. And just one quick thing to plug as well, in case you didn't see it in chat. I've gone through the effort of finding as many state reimbursement training programs that are out there. There's a good chance that your state has one, and I put a link in the chat for you to be able to go out and just check what the state that you have and see if there's a program. You can get from anywhere 25 to all the way up to 100% reimbursed for training classes that we provide. So fill out a form if you're interested in learning more. We can kind of help do some of that work for you and get you started. Thank you everyone this was awesome. This is probably the best webinar we've had so far. So thanks again. Have a good weekend, and yeah, make sure you reach out if you have any questions or want to get started with Fusion. Awesome.
Yep.
Well, thanks,
Thank you,
Brad. Thanks,
everyone.
Umair.
Thanks for
This
the
was awesome.
feedback.
Thanks,
Yep.
everybody. See ya.
Yeah. Take care all.